Audio Jungle. Audio Jungle.
So, like in last class, we had seen that derivation of uh, radius of turn, and we had seen time required to turn and rate of turn. Okay, so in short, I will show you that recap of previous few classes. Here, first we had seen radius of turn. Okay, then we had seen rate of turn. We had seen time required to turn. Yes or no? And one very important relation, that was before turning and after turning. Okay, what was that? Before turning, that all the parameters, it was before turning, or you can say it is steady level flight. Yes or no? So steady level flight, say thrust was T naught, say drag was D naught, say lift was L naught, say velocity was V naught, and say required power was P naught. But after turning it become thrust become what? P, drag become D after turning, or you can say during turning. Okay, but before turning and turning, two condition you have. Before turning means it was steady level flight. During turning, or you can say after turning, that parameters become T naught become T, D naught become D, L naught become L, and velocity will be V, and power required will be P. These are the parameters. Basically, this is what turning flight. Okay, we had seen this is the third lecture of the turning flight. So these are the things we had seen. Okay, last class. So because today we have to solve problem, so I will write the main formula and then we'll start numerical. Okay, so what is the formula of the radius of turn? Radius of turn I had derived in last class. It was R is equal to V square G tan phi is equal to V square G n square 1. This was the first formula we had derived, because today we have to solve numerical. So I'm just writing the important formula here. So we'll start uh, uh, that numerical part. Okay, then second is what? Rate of turn. Rate of turn, these are the important formula I'm writing. So we can start numerical. No? Omega is equal to what? It was G tan phi divided by V, or G n square minus 1 divided by Then third was we had seen it was time required to turn. What is the time required to turn? It is nothing but small t. It was endurance basically, time required to turn, and this is nothing but psi v g tan phi. Psi is the turning angle, phi is the banking angle. All the notification already I have given. So if you go and check previous lectures, you can understand. So this is the formula, okay, third formula. And one very important, that was relation. And what was the relation? I must write, this is the 1 mark question in gate. Okay, n is equal to load factor, which is nothing but sec phi for the turning flight, and this value was L upon L naught is equal to D upon D naught is equal to P upon P naught is equal to V upon V naught square is equal to P upon P naught to power 2 by 3. Okay, this was the relation, okay, formula. And this is, if you know this part only in turning flight, if you know this formula, so gate question you can crack. All good gate question, previous year gate question, if you check, depends on question they are asking based on this formula. If you know this formula, only 4 formulas are available here in terms of different banking angle and load factor. All the notification like what is r, it is radius, okay, of turn. What is the phi is the banking angle. What is the v is the velocity while turning the aircraft or during the turning of the aircraft. During turning, velocity is v. Okay, so I have here in first slide, if you check, this is the recap part here. All the like steady level t naught, d naught, l naught, v naught, p naught. Okay, thrust, drag, lift, velocity, and power required. P is the power required. Okay, what is the p? P is power required. Power required. Okay, pr. All right, and you know, simple sign convention. P is thrust, D is drag, L is lift. All those things I already explained, so no need to explain it again. This is in single pace. All the conclusion of the turning flight I have given here. Okay, if you know this formula, so you can hit the question. Okay, we'll solve the previous year question, and if you check 10-12 times question they have asked last 15-year question paper, if you check, then they had asked many questions from this chapter turning flight, and all the question based on this formula only. If you know this formula, you can solve simply. Okay, anyway, now so we'll start numerical. So first numerical will write very basic based on the formula. This is the problem number 1. Okay, an airplane an airplane has mass of 1500 kg, turning at speed of 200 kilometer per hour, and bank angle is 50 degree. Obtain center central force, comma, lip and radius of turn. This is the question. Okay, this is question. So directly this is question based on formula only. So check what data they have given to us. Given mass they have given how much? 1500 kg. Velocity turning at speed they have given 200 kilometer per hour is converted into meter per second. So it is 205 by 18. How much? Let me calculate. This is what 200 into 5 divided by 18. 55 point meter per second. Okay. Bank angle I have given the notation, it is phi. How much it is given? 50 degree. And remember banking angle is what always from the vertical plane. Obtain. Okay, find. What we have to find? Check. We have to find central force F. Okay. Lip force L and radius of turn R. So this is the problem there. Basic formula based problem. So we'll draw the diagram first for the turning flight. Very basic diagram. Check. This is the basic form diagram for the turning flight. I have drawn many times, so check it and draw. This is the what turning flight, right? This is the turning flight, okay? And if I show the force, different forces are acting here. So force, if I will resolve, so this is what downward force F or weight, sorry, weight, and I had explained you this will be what lift from the vertical plane or vertical axis. It is making angle phi, which is called banking angle. So this and this two component of lift you will get. This side it will be L cos phi and this side it will be L sin phi. Here somewhere this is the center. Okay, this is the center. About this center it is going to, this is the center point you can say. So about this center point it is going to turn. So turn radius will be R. Hope you understand. So obviously if it is turning in circular motion, because I told you turning flight it is the part of the circular motion. So here this side it will come centrifugal force. Away from the center will have a centrifugal force F, and this value is nothing but you know very well it is mv square by R. This is the centrifugal force. All right. So here they are asking, yes, we use mass because kg they have given. So wherever it is required, m, I mean mass need to write suppose mv square by R. So here m will be kg, but somewhere it is required in Newton, then you multiply it by 9.8. Okay. Now check. So we'll solve this. So what will be the solution? Fine. What you have to calculate first? Check F. F is the, they said central force. So what will be the central force F? F is nothing but mv square by R. But R is the unknown. You don't know what is the R. So R is the radius of turn. We have to calculate that. Okay. Because mass they have given, velocity they have given, and banking angle they have given. So you check what is the radius of turn formula. So R is nothing but in terms of the banking angle, check the formula we have written. This is the formula for the V square G tan phi, right? So we'll write this formula and we'll calculate V square. V is nothing but 55 point meter square. G is 9.8. You have to assume into tan. What is the angle they have given to us? It is 50 degree. So tan 50. So this r is the radius of turn. Definitely unit will be meter. So you calculate 55.55 square divided by 9.8 divided by tan 50. So I am getting here 2642. It is nothing but 264.21, right? 21 meter. Now you calculate the force. This is the first part. So what will be F? M is given how much? I think 1500 kg. Check. It is 1500 kg. Yes or no? Yeah. 1500 kg. So you write 1500. Velocity is 55 point square divided by r is nothing but 264.2. If you calculate this value, so let me write divide by 264.21. I am getting here 17519. This is the value. Okay, 17519. All right. So here I can write divided by 1000. It is nothing but 17.51 kilonewton. Okay, approximate. Check. Central force was first, radius of turn was third, and second value is nothing but lift. So first we have calculated radius of turn, third we have calculated. Now we'll go for the lift. 9 point is yes. Now that value, check. F is equal to what? Mv square by r, right? You don't multiply it by 9.8 again. Why? Because simply mass formula is what? F is equal to mv square by r. M is given in k. Obviously mass will be in kg. So write in kg. Velocity meter per second, r in meter. Directly whatever the value you will get, it will be Newton. Okay. What is the unit of the force? It is Newton. No need to multiply again 9.8. Understood? Anyway. Now, yes, now lift is nothing but what? L, and check if you balance the horizontal force here. So basically, see this L sine phi is equal to what? This force F. Yes. So you can write lift is nothing but L sine phi. You can write for the calculation of lift. What you will do? L sine phi you can write is equal to F. And F is nothing but mv square by r. Just now you have calculated. How much you have calculated? It is nothing but 17.51 kilonewton. So what will be the L? L is nothing but 17.51 kilonewton divided by sine 50 degree. So you just divide by sine 50 degree. It is nothing but 22.86 kilonewton. This is the value of lift. All right. Now, what you have calculated? First you have calculated force, second you have calculated lift, now third you have calculated r. All the value you please write. 22.86 kilonewton. F is nothing but 17.51 kilonewton, and radius, let me check how much. Radius was 264.2 meter. This is the answer. This was the only formula based problem. Okay, it's very simplest problem only, right? So another problem also we have based on the formula. If you check, it's very simple. Okay, it's very simple only. Fine. Now we'll go for the next problem. Check the problem number 2. This is the problem number 2. An airplane weighing 9,200 Newton, flying with a velocity of 50 meter per second in a steady state. The steady state and and level flight at 3000 meter, at 3000 meter altitude. Okay, where sigma, what is sigma? It is density ratio. Okay, remember, rho upon rho naught is given how much? 0.742. Always remember, this is called density ratio. Makes a 90-degree turn, 90-degree turn in 15 seconds. In 15 seconds, the wing area is 9 meters square and and drag polar equation and drag polar equation is CD how much? 0.02, 0.05 CL square, full stop. Estimate. So, but obvious, this type of lengthy question will not be asked in your exam. I mean, not a statement wise, I am saying, like estimate 3-4 value I will ask. Question size will be like this only. All the data they will give to you, half page data they will give to you, but they will ask only single question. Here I am going to ask multiple questions. So any one question will be asked to you in examination. Like estimate, I am going to ask 3-4 value. Like number 1, first is, what is the first value? Speed okay, yeah. I'll ask many value, but let me select what first I need to ask. Uh, Turning speed. Turning speed. Number 2 will be the lift during turning. Lift force, no? lift force, drag force, during turning. Okay, turning speed, lift, drag. Next value, thrust force or thrust during turning. Okay, power required during turning. Okay, then radius of turn. Okay. How many question? One, two, three, four, five, six. Any one question will be asked to you in examination. Understood? Any one question will be asked to you in examination. So there should not be any confusion like question cannot be so much lengthy in exam. Yes, that question size will be like this only. Statement size will be like this only. But any one question will be asked to you, like they can ask what is the thrust during turning, or they can say what is the radius of turn, or they can say what is the power required during turning, or power required for turn. Simple, power required during turning or power required for turn. Okay, or turning speed or speed for turn, like that. So this is the question. Hope you understood the framing of question. Now what we'll do, see, first you have to understand like this is the steady level condition for the flight. So for the steady level it is L naught lift and this is weight. Okay, it is like this is the aircraft, and for this aircraft, because it is steady level, so lift will be here. This will be what? Drag, and this will be what? Thrust. Notation is not, means velocity is V naught. For the steady level, this is what is steady level flight. Steady and level flight. Okay. So for steady level flight, this is what? Front view. This is what? Side view. Okay. Front view and side view. Yes or no? Front view and side view. So for the steady level flight, what are the variables, parameters? Velocity V naught, lift is L naught, thrust is T naught, drag is D naught. Yes or no? Power required is nothing but P naught. Whatever the power required, okay, power required to move this aircraft in forward direction will be P naught. But at the same time, suppose it is now aircraft is what going to turn. So that diagram will be like this only. Draw properly. Draw proper diagram. So you will have yes or no? Fine. All the forces here you have to show. This will be lift. It is banked, so banking angle will be there. L cos phi, L sin phi. This is what turning flight. Both diagram, hope you understood, right? This is the two different cases. Case one, it was a steady level flight, and second one is the turning flight. Yes or no? Now we'll check the data, and based on that data we have to check what value we can calculate. Okay, so here first I will check what they have given, given data. So given, if you check all the value here, you write weight they have given to us, flying with the velocity of this in a steady state level flight. Okay, and that altitude also they have given. You can say everything is what happening at some particular altitude. Suppose altitude is what here for the aircraft, it is 3000 meter or 3 kilometer. Okay, for both, no doubt about it. Turning is also on the same altitude. It is not like because it is the coordinated turning, right? Means altitude not going to change. 3 kilometer altitude from the sea level for both the diagram. Okay, hope you understood. Now we will write the data. What are the given data they have given? I'm writing from my notes. So weight is nothing but 9200 newton. All right, velocity they have given v naught, because it is the steady state level. Velocity they have given 50 meter per second. Altitude they have given to us 3000 meter, and sigma they have given to us, which is nothing but rho upon rho naught. Suppose density you want at that altitude, anywhere if it is used, then you can calculate that density directly. 0.742. Makes a 90-degree turn. What is the mean of it? Makes a 90-degree turn, where it is makes a 90-degree turn. So simple. If I draw another diagram for this, so you will understand easily. See, this is the aircraft now. Okay, yes, it is psi value, correct. So now this aircraft is what going to turn. So it is turned by 90-degree, means earlier it was going like this. Okay, now it is going to turn in this way, which is nothing but 90-degree, means your aircraft will be yes or no. Now this is the 90-degree turn for the aircraft. Yes, hope you understood. So basically psi is the turning angle, as I said that time, it is 90. You need to understand this. Okay, now it should be very clear. So psi they have given to us how much? 90-degree. Then we'll check the note. It is, what is the altitude where 15 second 90-degree turn in 15 second, means turning time they have to given to us, which is nothing but a small t. A small t is given how much? 15 second. Means what is that? It is the turning time. It is the turning time. The next is the wing area is what? 9 meter square. Drag polar they have given. So wing area they have given to us how much? Wing area is nothing but S. It is 9 meter square, and drag polar CD they have given to us how much? 0.02 plus 0.05 CL square. These are the given data. Okay. Now to calculate all the value here, what they have given, like turning speed, lift during turning, drag force during turning, thrust during turning, power required during turning, okay, radius of turn, these are the values. So you do one thing, you just find two things: steady and level flight, okay, steady and level flight. Whatever the value they have given to us, whatever the value they have given to us for the steady level flight, if we know that value, okay, then if we know the load factor, we can use this formula. Check, we can use this formula, fourth number formula, last formula. See, if you know load factor only, this is what load factor. Yes or no? If we know the load factor, then this ratio we can use and we can calculate all that value. Yes or no? Because one is steady level, another is turning parameter. Yes. So only load factor if you know, and steady level value if you know, then whatever the value will be during the turning, you can calculate by that formula only. Yes or no? That is our approach basically. Now, so check steady level velocity they have given to us. How much it is given? 50 meter per second. All right. And second thing, if you check what they have given airplane weight. They have given what is the weight of the aircraft. It is nothing but for the steady level it is lift, and during the uh, what steady level, lift is equal to weight, and steady level value is nothing but not value, means L naught. So what is the weight? Steady level weight they have given 9,200 newtons, so means lift they have given to us. Yes or no? They have given lift also. Rest value will calculate, because velocity and weight for the steady level will know. Okay, right. So what we'll do, anyhow, if it is possible to calculate phi number one, then it is okay. Or else if you know the load factor anyhow, that will also one way to find uh, like turning value, if you know the load factor. So check any formula here, because in that phase I had given all the formula, and with the help of this formula only you have to go, okay, to solve the problem. Check here. So basically, time required to turn this, t they have given to us, psi they have given to us, v they have given to us, okay, but this v is what? Turning velocity. But in I mean, here in this problem they have given velocity at steady level, not turning, but we'll convert this velocity in turning with the help of that load factor. Yes or no? G tan phi. So what we'll do, we'll write the formula, time required in terms of load factor, and this velocity will also be okay. I will write the formula, then I will explain you, so you will understand it, you know. Check. Now what we have, very importantly, what we have, time they have given to us, time required to turn the aircraft. And what is the time required to turn the aircraft? That formula is nothing but psi v g tan phi in terms of banking angle, or you can write psi v in terms of load factor. This is what? N. Now this is what? N. Yes or no? This is what? N. N square. Alright. Now, so what I wanted to tell you, this is psi, it's okay, but this velocity is the turning velocity. But here in the problem, what they have given, they have given velocity at steady state level. Yes or no? Right. Now, so what you will do, you can write the relation for the velocity in terms of load factor. What is the velocity relation? You can check v upon v naught square is equal to what? N. Yes, or it is nothing but sec phi. Yes or no? So what is the v? V is nothing but, if you check this value, so it will be root of n into v naught. You can write this. How, where you will get this formula? See, already I have written this formula. Okay, so there should not be any confusion about this formula, no? Check that space, I had given this formula now in starting only. So simply you just use this. Then you v, instead of v, what you can write? Root of n v naught divided by root of n square 1. Now this is the complete formula for us. All right. What you can write here? Psi upon g into v naught n upon n square minus 1. You can write this. Okay. Now, so you have to write the value given. What is the given value for the time t? It is nothing but 15 seconds. 15 seconds. Okay, is equal to psi is the what? It is in degree. How much it is given? Psi. It is given 90 degree. This because formula you are going to use. If there is no sine, cosine, tan, sec, if it is not there, then this 90 degree must be in radian. So you convert this 90 degree into radian. What you will do? 90 into, what you will do? This value you have to convert into radian. Okay, because it is in degree here. Na? So you know that you just multiply by pi upon 180. So it is nothing but pi by 2. This is now in radian. Hope you understood this. So pi by 2. So psi is nothing but pi by 2 into what is the g? It is nothing but 9.8. What is the v naught? Velocity they have given to us. It is 50 meter per second. 50 meter per second, and this is nothing but n upon n square. You calculate load factor n. Okay. If you calculate this load factor, so you may get this coordinating value. Okay. If you solve this, so two value of the load factor you may get, maybe one you may get less than 1 or negative. Okay, one value will be greater than 1. So what value you have to choose in that situation? You have to choose greater than 1. Why? Because in first class only I had explained, for the turning flight load factor is always greater than 1. For the climbing and gliding flight load factor is always less than 1. For the turning flight, load factor is always greater than 1. So if you solve this equation coordinating, because n upon n square minus 1 we have, if you solve this coordinating equation, so two value of the n you may get. One value you may get less than 1, or maybe it is negative. Okay. And one value you may get greater than 1. So greater than 1 positive value or accepted value you have to take. Okay. Hope you understood. Can you tell me that load factor two different value n? So that you have to take care of it. Okay, that load factor two different value you may get. Okay, so whatever the value greater than 1, accepted value will be what I am writing here. It is nothing but 1.152. This is the one accepted value for the, you guys can calculate. Okay, that n value. So two different n value you may get. Because of the time constraint, I cannot wait for the that lengthy calculation. So I am writing here n is nothing but 1.152. This is the acceptable. Okay, because it is greater than 1. Hope you understood. And for the turning flight, load factor must be greater than 1. Anyhow, if you know the load factor for the turning flight, then you can write the relation. What relation you have? That relation is what very beautiful relation. It is nothing but, I must write, it is nothing but n is equal to L upon L naught, D upon D naught, okay, T upon T naught, yes or no? And is equal to V upon V naught square is equal to P by 2 by, all right. Fine. So now check what you have to calculate first. So guys, I am telling you, I am solving this lengthy numerical and only one part will be asked to you in examination. Why I am solving this lengthy problem? Because if I will solve this full problem, so you will be the master for turning problem, okay? And if you practice one single problem only, then any gate question you can simply solve, okay? Okay, you have to believe this and you have to solve even previous year question paper. You can start solving, then definitely you will understand the power of this one numerical. I mean, in this one numerical, single numerical, everything I'm calculating. So for that reason I'm saying you just focus this problem. It is so much lengthy, but it's okay. Now what I was saying, what you supposed to calculate, you're supposed to calculate first turning speed, means v they are asking. You have to calculate v anyway. So direct use the formula here only. See, n is equal to v upon, what will be v? V is nothing but, or root n. What is that value of n? You got 1.152, 1.152 into what is v naught? It is 50. If you calculate this, what you may get? 1.152, okay, into 50. It is nothing but 53 point. What I am getting, I am just writing you that you can cross check this. It is nothing but 53.66, right? It is nothing but 53.6 meters, right? Number one. Number two, what you have to calculate next? Lift force during turning. Good. Lift force during turning. How to calculate lift force during turning? So first you should know what is the lift force during steady state level flight. What is the lift force during steady state level flight? It is the weight. Okay. So second one is nothing but n is equal to L upon L naught. What is the L? L is nothing but for the steady level flight, it is nothing but weight. So steady state level flight, what are the parameters? It is the L naught. So L upon L naught will be nothing but weight, because for L naught is what? It is a steady state level parameter. So for the steady state flight, lift is equal to weight. So L by W. Now L you can calculate how much it is, N into W. Yes or no? N into W, and if you check, it is 1.152 into what is the weight? Weight is nothing but 9,200 Newton. So 1.152 into 9,200 Newton. It is nothing but 10 point, or this is the lift during the turning. Okay. Right. Now you have to this is what, two number. Okay, two number you have calculated. Third one is, I think, drag. So for the drag, third one is the drag. So for the drag, CD you need to know, and for the CD you need to know CL. CL is the constant value, so you need to calculate. Okay, CL. How you can calculate? You know, for the steady level it was L naught is equal to W is equal to half rho V square S into CL. Yes or no? Right. So what is the CL? And remember, this is L naught, hence this velocity will be V naught. There should not be any confusion. And this density you need to calculate at 3 kilometers. So what is that ratio they have given to us? Rho upon rho naught is equal to, check that ratio they have given, 0.742. What is the density at 3 kilometer altitude? 0.742 into rho naught. Okay, what is the rho naught? Rho naught means sea level density 1.22 kg per meter cube. So what will be the rho at 3 kilometer? Because you have to calculate this value CL and all at 3 kilometer altitude. Okay, because aircraft is what at 3 kilometer altitude, so there should not be any confusion. So this is what 0.742 into 1.22. How much it is? Rho 3 kilometer. This is nothing but 0.742 into 1.22. How much it is? 0.9052 kg per meter cube. All right, this is the value. What will be the CL? CL is nothing but 2 W divided by rho. Okay, this is the CL. 2 into what is the weight at sea level? Weight at sea level, it is given how much? 9,200 Newton. Check the problem. Density at 3 kilometer you have calculated 0.9052. Velocity at steady state level, it is nothing but 50 square, means 50 they have given to us. What is the area? Area S. You please write the data. Now, every time I cannot go back slide, otherwise it will take so much time. So 9 meter square is the area. So calculate CL. So okay, 2 into 9200 divided by 0.9052 divided by 50 square divided by 9. How much it is? I am getting 0.90, or you can say 0.9. That is more than enough. Yes or no? Ah, yes, it's 0.90, 0.903. Then from drag polar, what is the CD? Please check the CD value. It is nothing but 0.02 plus 0.05 CL square. Please calculate this CD. This drag polar they have given. This is given value. In problem itself it is given. Now if you calculate CD, so how much you may get? Plus 0.02. I am getting 0.06. 0.06. Hope you are also getting, yeah, 0.0608. Very good. Yes, correct. Fine. So what will be the drag then? Drag force is what? Half rho v square s into CD. This drag means at steady level I am interesting to calculate. Okay. At steady state level I am interesting to calculate this value. So I should write D naught. This density will be 3 kilometer, no problem. And this velocity will be V naught, and CD is no problem because it is constant. So it is 1 by 2. Density is nothing but 0.9052. Velocity is 50 meter square. S is 9 into CD is 0.06. So what will be the drag value? D naught. Please calculate this. 0.9.50 square, 0.9052 divided by 2. I'm getting 619. I don't know if it is correct or not. Please calculate. 619.24 Newton. Check. Yeah. This is the D naught. Hope you understood what is the mean of D naught. D naught means sea level. Sorry, not sea level, means steady state level. Drag is what? At steady state level. At steady state. Now by the symbol only you can understand. If I am writing D naught, it means it is the steady state level. Okay. There should not be any doubt about it. Done. Now we'll go for the calculation for the drag at or we can write drag during turning flight. Okay, drag during turning flight. What is the formula for it? Check. N is equal to d upon d naught. So what is the number here? Third, no? N is equal to d upon d naught. So okay, now what is the drag during the turning? Or it is n d naught. Please calculate what is the value of n. It was 1152 into d naught. Just now you have calculated 619.24. How much? 1.1525 713, right? Is 713 713.67 Newton. It is the drag during the turning. Next, thrust during turning. Okay, what is the formula for it? Right. So for turning thrust, it is N is equal to P upon T naught. Yes or no? So obviously that formula will be, because it is the same, like T is nothing but N times T naught, and N into, for the steady state level, T naught is nothing but D naught. So what you have done here, the same thing will have 713.67. Yes or no? This will be the thrust. Because check the formula. That formula itself is saying the same thing. N is equal to D upon D naught is equal to T upon T. Alright. So you can calculate in this way. Now, what is the next data we have to calculate? It is nothing but power required during turning. So what is the power required during turning? Take the formula. It is N is equal to P upon P naught 2 pi power 2 by 3. So power required during turning. What is the formula? N is equal to P upon P naught 2 by 3. What is the P naught? It is the power required at a steady state level. What is the power required at a steady state level? Drag into velocity, D naught into V naught. Agree with this? This is the power. Yes or no? D naught into V naught. So you have calculated what is the D naught. What is the D naught? 619.24. 619.24 into what is the V naught? It is given how much? 50. If you calculate this, yeah. If you calculate this 619.24 into 50, if you do this, you will get 30962 watt. Yes or no? Then what is the power during turning? It is nothing but n to power 3 by 2 into P naught. Agree with this? Now you can calculate this value. So check into what is the n. N is 1.15 1.152 1.152 to whole power 3 by 2 means 1. So here I am getting P8 283.15 watt, no? Or you can say 38.8 kilowatt. All right. No, not 35 cross. Okay. Yes. That value here, P naught. Steady state level, how it is 35 cross check. No, should be D naught 619 cross check. Fine. That last is the radius of turn. Okay. What is the last one? Right. Radius of turn. What is the radius of turn? It is nothing but formula if you write V square by G tan phi, or you can say V square by G. Now you have velocity during turning. Okay, you have calculated how much you have calculated, or else if you want this, you can write. I mean, you can write V naught in terms of that also. You can write root n. It's your choice, because V naught and V both you have now. It's your choice in what format you want to calculate. If you do this, anything you can keep here. If you write V, then this value you have to write. Okay, somewhere you have calculated now here. Then 53.66 you have to write. If first formula if you want to write, then here. If you want to use this formula, so you have to write 53.66 square divided by 9.8, 1.152 minus 1. This is square. If someone is not using this formula, then this formula will be 50. Okay, this is nothing but 1.152 divided by 1.152 square. It's your choice what you want to write. Both will be same. If you calculate how much you may get, check. Is approximate 513 point. Okay. Next is number 7. Okay, here I have not, I think, asked you. Please add one more thing. One more you have to add here. The problem. This 7. It is nothing but rate of turn. Please add one more. Rate of turn. Rate of turn. So last is 7 number. It is called rate of turn. Okay, it is nothing but omega, which is nothing but v by r. If you solve it, you may get g tan phi divided by v, or you can say g root of divided by v, or in terms of v naught if you want to write. It's your choice. So I'm explaining everything. It's your choice what you want. Okay, this is the formula. Any formula you can use, no? Understood? You are writing v or v naught, it's your choice, no? So I'm writing b. So b is 53.66. Yes or no? if you calculate this value, so check what you are getting. If you calculate this value, check what you are getting now. So 1.152 square minus 1, take root of it into 9.8, divide by 53.6. So it is nothing but 0.104 radian per second. I think this is the value. Check. Rate of turn. Okay, the same thing. 0.09. If round off, then it is 0.1. So here check whatever the possible thing. I mean, for this particular one single problem, I have taken all the considerations, means all the parameters in both way, like compared things like steady state level and what it is called turning flight. Now different question they can ask. Even they ask the comparison also, like they will say, okay, power required will be higher than power required during turning will be higher than steady state level, yes or no? Yes. Velocity during the turning is less or high compared to steady state level, you can answer for that. Lift, drag, okay, velocity, thrust, everything. I mean, you can compare all the data. Now magnitude you have, so you can compare by your own, or just single formula. If you remember this formula, that time also you can answer, because is this n is always greater than 1 for the turning flight, there should not any confusion. Then you all the parameters you remember, simple. So I hope you all understood this. Yes or no? I hope you all understood this. For the today's session, this problem was lengthy, but all the parameters here you have calculated. Whatever the possibility in turning flight, I have solved. I have considered everything, and I'm sure this problem will help you out. Help you out. Okay, and fine. Now, so done.